Every picture you have ever seen of an alien world is a guess, and almost all of them are wrong. We imagine other planets as barren, dead, grey rock under a black sky, or red dust to the horizon, or some boiling hellscape no living thing could ever touch. We have been taught to think of Earth as the exception, the one warm room in a cold and empty house, the single place in the entire solar system where rain falls, where rivers run, where clouds drift across the sky and weather happens and liquid pools in the low places of the land. And that picture, the one you have carried since childhood, is wrong. Because there is a second world, a second place where it rains, where rivers carve valleys and empty into seas, where wind shapes dunes and clouds gather over the poles and storms break, and the weather changes with the seasons. It is not a distant exoplanet hundreds of light years away, glimpsed only as a dip in a star's brightness. It is here, inside our own solar system, closer than you think, and it has been hiding this entire time behind a veil of orange smog so thick that for 300 years we could not see its surface at all. Its name is Titan. It is a moon of Saturn. And tonight, you are going to stand on it. You think you know what the worlds of our solar system look like? You do not. Not this one. Because everything that makes Titan extraordinary is hidden, wrapped in a haze the color of old amber, sealed beneath an atmosphere so deep and so strange that until very recently, it was one of the last great mysteries left in the catalogue of the planets. If you want to see a world that breaks every rule you were taught about what other worlds are supposed to be, hit that like button and subscribe. It genuinely helps this channel reach other quiet minds, drifting and curious in the dark hours of the night. And now, let your shoulders drop. Let the weight settle out of your hands, let your breathing slow and your eyes close, and let the room around you grow soft and far away. We're going to take a long, slow journey tonight, out past the asteroids, out past Jupiter, out to the ringed planet and the great orange moon that circles it. There is no hurry. There is nowhere we need to be. Let's begin. Close your eyes and picture the solar system the way you always have. The sun at the center, warm and gold. The small rocky worlds huddled close to its fire. Mercury, scorched and tiny. Venus, smothered in cloud. Earth, blue and alive. Mars, rust red and thin. Then the long dark gap, the field of broken stone we call the asteroid belt. And then the giants. Jupiter, enormous and banded, Saturn with its impossible rings. And then, far out at the cold edge of the picture, the two pale ice giants, Uranus and Neptune, almost forgotten, almost off the page entirely. That is the map in your head. That is the map in almost everyone's head. And on that map, the moons barely register. They are footnotes, specks, tiny dots orbiting the important worlds, too small to matter, too cold to be interesting. You were taught the names of the planets in school. You were probably never asked to learn the names of the moons. They were background, set dressing, the supporting cast in a story that was always about the planets. But the map is wrong, and the moons are not footnotes, because out there, circling Saturn, there is a moon larger than the planet Mercury, a moon you could not see across even on the clearest day, because it is wrapped in weather, a moon with a thick golden sky and slow falling rain, and seas you could sail a boat across, and a landscape so eerily, hauntingly familiar that the first time human eyes saw photographs of its surface, the thing that struck people hardest was not how alien it looked, it was how much it looked like home. River channels, shorelines, smooth stones rounded by flowing liquid, a horizon, soft and hazy, exactly like a foggy morning on Earth. And yet every single detail of that familiarity is built from materials so cold and so strange that if you stepped out onto that surface unprotected, you would freeze solid before you finished your first breath. This is the paradox of Titan. The most Earth-like place in the entire solar system is also one of the most lethal. It is a frozen mirror of our own world, showing us a reflection of home rendered in ice and gasoline and bitter cold, 4 billion years deep in the dark. So let us go there, slowly. Let us cross the distance first, because the distance itself is part of the story, and feeling the distance is the only way to understand just how far from home this second shore really is. Start with something you can almost feel, the distance from the Earth to the Sun. We call it 1 astronomical unit, and it is about 93 million miles. That number is already too big to hold, so translate it into something your body understands. If you could drive a car to the sun at highway speed, 60 miles an hour, never stopping, never sleeping, never slowing for anything, the trip would take you more than 170 years. Generations would be born and would die in that car before it arrived. That is 1 astronomical unit. That is the distance from here to the star that warms your face. Hold that in your mind. 1 unit, the length of the leash that keeps the Earth in its warm orbit. Now go outward. Mars, the next world out, the red planet we dream of reaching, sits at about 1.5 astronomical units from the Sun. Close, in the scheme of things. Then comes the asteroid belt, a scattered field of rubble between 2 and 3 units out. Then Jupiter, the king of the planets, at about 5 astronomical units, 5 times the distance from the Earth to the Sun. Already the sunlight out there is weak, a small bright disk, rather than a warm fire. And then Saturn, the ringed world where we are going tonight, orbits at about 9.5 astronomical units from the Sun, almost 10 times farther from the Sun than we are. Take that car again, the one driving at 60 miles an hour. To reach Saturn, you would not drive for 170 years. You would drive for more than 1,700 years. The whole of recorded history, the rise and fall of every empire you have ever read about, would pass while the car was still on the road, still driving, still nowhere near the rings. Light is faster than any car. Light is faster than anything. And even light, which crosses the gap from the sun to your face in a little over 8 minutes, takes its time getting to Saturn. From the sun, a beam of sunlight needs about 80 minutes to reach the ringed planet, an hour and 20 minutes travelling at the absolute speed limit of the universe, just to arrive. When you look at Saturn through a telescope, you are not seeing it as it is. You are seeing it as it was 80 minutes of sunlight ago, and then however many more minutes it took that reflected light to cross the gulf back to your eye. Everything out there is delayed. Everything out there is a little bit in the past. The solar system is so large that the present moment, the simple shared, now that you take for granted, frays and stretches across it until the worlds are not really living in the same instant at all. This is the distance Titan lives at. Not 5 minutes away, not 5 hours away, roughly 9.5 astronomical units from the Sun, locked in orbit around Saturn, nearly 900 million miles from the warmth of home. When the engineers and scientists of Earth wanted to send a machine out to touch it, the machine did not take a week, or a month, or even a year. The spacecraft that finally reached Saturn, a probe called Cassini, launched in 1997 and did not arrive until 2004. 7 years in transit, 7 years of falling through the dark, slingshotting past Venus, past the Earth again, past Jupiter, borrowing speed from each world it passed, building up the velocity it needed to cross that impossible gulf. A child born the week Cassini launched would have been in school, reading and writing, by the time it slipped into orbit around Saturn. That is what the distance means, not a number, a span of a human life. And out there, that far from the sun, the cold is not the cold you know. It is not winter cold. It is not the cold of the deepest night you have ever stood in. On Titan, the temperature at the surface hovers around minus 179 degrees Celsius, minus 290 degrees Fahrenheit, so cold that the very idea of warmth becomes meaningless. So cold that water, ordinary water, the most familiar substance in your life, is not a liquid and is not even a soft thing. On Titan, water is rock. The ground beneath your feet, the hills, the bright bedrock that shows through in places, much of it is water ice, frozen so hard and so deep that it behaves exactly the way granite behaves on Earth. You could build a house out of it. You could shatter a hammer against it. The water that makes up your body, the water that fills the oceans of your home world, out here, is simply stone. Cold, pale, permanent stone. So hold all of that as we approach, the distance vast beyond the reach of imagination, the cold, deeper than any cold you have a word for, and the strangeness, waiting underneath the haze. We are coming up on it now. Saturn fills the sky, a vast banded ball of pale gold, ringed in ice, and circling it one bright point among dozens of moons, growing larger as we approach, is a single fuzzy sphere the colour of a dying candle flame. No sharp edges, no visible surface, just a soft, glowing orange ball, featureless and smooth, like a marble of frosted amber held up to a weak light. That is Titan. That is the veil, and we are about to go through it. But linger for just a moment here in space before we descend, because the view from out here before the haze swallows everything is one you will never get again once you are down on the surface. Behind the orange moon, filling a vast swath of the sky, hangs Saturn itself. Not a picture of Saturn, not a dot in a telescope. Saturn, enormous and close, a great banded sphere of pale gold and cream and soft butterscotch, its colours layered in broad, smooth stripes, calm and luminous. And around it, the rings. The rings that no description has ever truly captured, sweeping out from the planet in a vast, flat sheet so wide you could lay dozens of Earths across them side by side, and yet so astonishingly thin, only tens of meters thick in places, that when you see them edge on they nearly vanish. They are made of countless billions of pieces of ice, from grains the size of dust to boulders the size of houses, each one a tiny moon on its own orbit, all of them together, catching the distant sunlight and glowing, a luminous halo of ice circling the golden giant. From out here, Near Titan, the whole scene hangs in the black, like the most beautiful object ever made, the ringed planet and its great orange moon, drifting together through the dark 9.5 astronomical units from the sun, alone in the enormous quiet of the outer solar system. And there are other moons out here too, dozens of them scattered around Saturn like a family. Tiny Enceladus, bright white and clean, with its own buried ocean of water, spraying geysers of ice and vapour into space from cracks at its south pole, feeding one of Saturn's faint outer rings with its breath. Battered Mimas, with one enormous crater that makes it look like a single great eye. Iapetus, half bright and half dark, two-toned and strange. Dozens of smaller worlds, lumps of ice and rock, shepherding the rings, tumbling through the dark. But none of them are like Titan. None of them are wrapped in weather. None of them have rain or rivers or seas or a thick golden sky. Among all the moons of Saturn, among all the moons in the entire solar system, Titan stands alone. The one with an atmosphere you could lean against, the one with a landscape shaped by falling rain, the one world out here in the cold that wears the same kind of face our own world wears. So take one last look at the rings glowing in the dark, and the golden planet, and the scattered family of icy moons, and then turn back to the orange sphere before us, and let us go down, down through the haze, to the surface no eye on Earth has ever seen. For 3.5 centuries that veil kept its secret. A Dutch astronomer named Christian Huygens first saw Titan in 1655, a faint point of light beside Saturn, moving night after night, clearly a moon. He had no idea what it was. For the next 300 years, no one did. Through every telescope ever pointed at it, Titan remained that same maddening thing. A smooth orange ball, no markings, no surface features, no mountains, no craters, no hint of land or sea. Every other large moon in the solar system shows you its face. Our own moon shows its grey seas and bright highlands to the naked eye. Jupiter's moons show their colours and their scars through a backyard telescope. But Titan showed nothing. It hid. And for centuries astronomers simply assumed they were looking at the surface, and that the surface happened to be a featureless orange desert, dull and uniform and uninteresting. They were wrong. In 1944, an astronomer named Gerard Kuiper made a discovery that should have changed how everyone thought about that little orange world. He found that Titan had an atmosphere, a real one. He detected the chemical fingerprint of methane gas wrapped around the moon, and suddenly the smoothness made sense. We had never been looking at Titan's surface at all. We had been looking at the top of its sky. That bland orange ball was not a desert, it was a planet-sized ball of weather, and the surface, whatever it was, lay hidden far below, sealed beneath a layer of cloud and haze so complete that not a single ray of ordinary light could carry an image of the ground back up to space. Titan was not boring. Titan was wrapped, and it would take us another 60 years, and one of the most audacious feats of exploration our species has ever attempted, to finally pull back the wrapping and look underneath. And we tried to look. As soon as we had spacecraft that could reach the outer solar system, Titan was a prize that scientists could not resist. The first to pass nearby was a probe called Pioneer 11, which flew through the Saturn system in 1979 and sent back the first close pictures of the orange moon. They showed almost nothing, just the same featureless haze, a little closer. And then came Voyager 1, one of the most famous spacecraft ever launched, sweeping through the Saturn system in 1980. And here the scientists made a remarkable decision, one that tells you how badly they wanted to understand Titan. Voyager 1 could have been sent onward after Saturn on a path that might eventually have carried it to Pluto, the one planet no spacecraft had ever seen. Instead, the mission planners chose Titan. They aimed Voyager 1 for a close pass of the orange moon, knowing that the flyby would fling the spacecraft up and out of the plane of the planets and end its tour of new worlds forever. They gave up Pluto for Titan. They decided that a close look at this one strange moon was worth more than a first look at a whole unseen planet. And what did Voyager 1 see after all that, as it swept past the moon they had sacrificed so much to study? Nothing. The same orange haze, the same smooth, featureless, impenetrable veil. Voyager confirmed the thick nitrogen atmosphere, measured its pressure and its temperature, and proved that conditions on the surface might allow strange liquids to exist, but it could not see the surface itself, not one feature, not one glimpse of the ground. The moon kept its secret even then. We had crossed the entire solar system, given up a planet to get there, and Titan still would not show us its face. It would take another 25 years, and the Cassini spacecraft, and the little Huygens probe falling on its parachute, before that veil was finally pulled aside. Some secrets the universe gives up only to those who are willing to wait and to come close, and to fall all the way down through the dark, to touch them. So let us do what they did. Let us descend. Imagine you are falling toward Titan now, not as yourself, not yet, but riding inside a small machine, a probe shaped like a shallow bowl, plunging into the top of that orange atmosphere at thousands of miles an hour. This really happened. On the 14th of January 2005, a probe called Huygens, named for the man who first spotted the moon, separated from the Cassini spacecraft and fell into Titan's sky. It is the only landing humanity has ever made in the outer solar system. The farthest touchdown we have ever achieved, and everything we are about to experience together, the layers of haze, the slow fall, the first sight of the ground, is built from what that little probe actually saw and recorded as it dropped through the air of an alien moon, nearly 900 million miles from the people who built it and held their breath and waited. You hit the atmosphere high up, hundreds of miles above the surface, and at first there is only violence, the friction of entry, the heat, the buffeting. But the atmosphere is so deep, so tall, that there is an enormous amount of room to slow down. This is the first surprise of Titan. Its atmosphere is huge. It reaches far higher above the surface than Earth's does, stretching hundreds of miles up into space, a sky so deep that an airplane would have to climb for an impossibly long time before it ran out of air to breathe. A parachute opens, the wild speed bleeds away, and now you are no longer crashing, you are drifting, floating down through the layers of an alien world, slowly enough to look around, slowly enough to feel it. The descent will take more than 2 hours. There is time. There is so much time. Let yourself sink into it. At first, there is only orange, a thick, uniform, glowing haze in every direction, the colour of weak tea, the colour of a street lamp seen through fog, the colour of the inside of a sealed amber room. You cannot see the surface. You cannot see the sky above. You cannot see anything but the soft, luminous orange of the haze itself, lit from within by the faint scattered sunlight that filters down from far overhead. This haze is not water vapour, the way Earth's clouds are. This is something stranger. High in Titan's atmosphere, sunlight strikes the methane and nitrogen gas and breaks it apart, and the fragments recombine into heavier and heavier molecules, complex chains of carbon and hydrogen and nitrogen, organic compounds that drift and clump and form a fine smog of tiny particles. Scientists call them tholins, from a Greek word meaning muddy. They are the reason Titan is orange. They are the reason it hid for 300 years. A perpetual, planet-wide smog of organic molecules slowly raining down out of the sky, coating everything below in a fine, dark residue, the soot of a chemistry that has been running uninterrupted for billions of years. It is worth understanding where this haze comes from, because it is one of the most extraordinary things about Titan, a kind of slow chemical factory running across the entire sky. Far above you, hundreds of miles up, at the very top of the atmosphere, sunlight and the faint rain of charged particles from space strike the gas of Titan, the nitrogen, and the methane, and they break those simple molecules apart. The fragments are restless. They recombine and recombine again, building larger and larger molecules, chains and rings of carbon and hydrogen and nitrogen, growing heavier with every step, until they are too heavy to stay aloft and begin, ever so slowly, to drift downward. These are the tholins, a name coined decades ago by the astronomer Carl Sagan, from a Greek word meaning muddy, because no one could give them a single simple chemical formula. They are not one substance, they are a whole family of complex organic molecules, the soot of sunlight working on air, and they are what give Titan its colour and its veil. The entire orange sky is, in a sense, a vast and ceaseless chemistry experiment, running on sunlight, building the molecules of organic chemistry out of nothing but gas and light, and then letting them fall slowly, like a fine dark snow, onto the world below. Think about what that means. Every particle of haze you are drifting through right now was assembled molecule by molecule, high in the sky, by the touch of distant sunlight on simple air. And every one of those particles is slowly falling, has always been slowly falling, for billions of years, settling out of the sky and accumulating on the surface, coating the dunes, darkening the plains, building up across the whole face of the moon into a layer of organic material that may be hundreds of feet deep in places. Titan is raining the building blocks of chemistry onto itself, constantly, gently, and has been since before the Earth had life. The haze is not just something in the way, the haze is the moon making the very stuff that, on another world, in another place, under slightly different conditions, might one day stir and combine and wake up into something alive. You are falling through the raw ingredients of biology, suspended in the air of an alien moon, glowing softly orange in the weak and distant light of the sun. And as you sink lower, the haze begins, very gradually, to thin. The orange grows less uniform, shapes begin to resolve far below you, dim and brown and indistinct, like land glimpsed through heavy fog from a descending plane. And slowly, impossibly, you begin to realize that you are looking at a landscape, not a smear of colour, a place with features, with structure, with the unmistakable heart-stopping signature of a world that has been shaped by flowing liquid. There are channels, branching, winding, tree-like networks of dark valleys cut into pale high ground. They fork and join and fork again, narrow tributaries gathering into wider ones, exactly the way streams gather into rivers on earth, exactly the way rain runs off a hillside and finds its way downhill and carves the land as it goes. There are bright highlands, rugged and rough, and dark lowlands, smooth and flat, with the channels running down from the high country into the low, draining towards some basin you cannot quite see. When the first images of this came back from the Huygens probe, the scientists watching were stunned into silence, because they were looking at a drainage system, a watershed. The fingerprint of rain, liquid had fallen from this sky and run across this land and carved these valleys and pooled in these basins. The most familiar process in all of geology, the slow, patient work of rain and rivers, was written across the face of a moon nearly 1 billion miles from Earth. The only difference, the staggering difference, was the liquid doing the carving, because on Titan it does not rain water, it rains methane, it rains the stuff we burn for fuel. The rivers are rivers of fuel, the rain is rain of fuel, and the seas those rivers run down to fill are seas of liquid natural gas, cold enough to freeze a human being into glass. And now the probe touches down, the fall ends. After more than 2 hours of drifting through the orange, the bowl-shaped machine settles onto the surface of Titan with a soft crunch and comes to rest. And for the first time in the history of the world, a working camera sits on the ground of a moon of Saturn, looking out at the horizon. And what it sees, what it sends back across that vast gulf of space, is a scene of almost unbearable familiarity. A flat plain stretching to a soft, hazy horizon, an orange-brown sky, dim as a deep dusk, and scattered across the ground, all the way to the edge of sight, rounded stones, pebbles and cobbles smooth and water-worn, exactly like the rounded stones you would find on a riverbank or a beach on Earth. Stones rounded by tumbling, by flowing, by the patient action of liquid moving them and grinding them and wearing away their edges over uncounted years. Except these stones are not rock, they are water ice, frozen harder than granite, scattered across a damp plain at the bottom of an alien sky, smoothed round by rivers of methane that had run there, perhaps recently, perhaps long ago, leaving the ground beneath the probe slightly soft, slightly damp, like sand at the edge of the tide after the water has pulled back. Now stop falling, stop being the probe, let the machine go and put yourself there instead. Stand up in your imagination on the surface of Titan and let us look around slowly and feel, one sense at a time, what it would actually be like to be a living, breathing presence standing on this second shore. The first thing you would notice is the light. It is dim, not dark, not night, but dim, the way the world looks in the last 20 minutes of a heavily overcast winter evening just before you would reach to turn on a lamp. Titan is nearly 10 times farther from the sun than Earth, and sunlight out here is already weak, perhaps 1/100th of what falls on your skin at home. And then that weak sunlight has to fight its way down through hundreds of miles of orange haze, scattering and dimming the whole way, so that by the time it reaches the ground, only the faintest fraction is left. The daylight on Titan, the full brightness of high noon, is roughly 1,000 times dimmer than the daylight, you know, and yet it is not black. It is a warm, soft, even glow, the entire orange sky luminous and shadowless, like standing inside a paper lantern. There is no blue, there is no white, there is no sharp blade of direct sunlight and no crisp black shadow, only that deep, gentle, amber light falling evenly from every part of the sky at once, soft as candlelight, soft as the glow behind closed eyelids. It is, by all accounts, one of the most peaceful qualities of light anywhere in the solar system. A perpetual golden dusk that never deepens into night and never brightens into day. Just the long, even, endless evening of Titan, going on and on across a frozen land. And the ground beneath you is its own quiet marvel. When the Huygens probe settled onto the surface, it did not land on hard rock, and it did not splash into liquid. It landed on something in between, a surface the engineers described as being like wet sand or like soft snow, or, in one memorable comparison, like the thin crust on top of a creme brulee, a firm skin over a softer, slightly damp material underneath. The probe pressed a few centimeters into it and stopped. Beneath the outer layer, the ground was moist, dampened with liquid methane that had soaked into it like water into a riverbank. So the surface of Titan, in that one place we have actually touched, is not the hard, barren rock you might picture on a frozen moon. It is soft, it is yielding, it is damp. It is a shoreline in the truest sense, the wet margin where a methane sea meets an icy land, and it would give gently beneath your boots, and hold the shape of your step, the way damp sand holds a footprint at the edge of the tide. Somewhere on Titan right now, the single footprint-shaped dent left by a small probe from Earth is still there, pressed into the damp ground, the only mark our species has ever made on the surface of that world, slowly gathering the dark soot of the falling haze. The second thing you would notice, if you could feel it, is the air. And the air on Titan is one of the strangest and most wonderful things about the entire world, because Titan is the only moon in the solar system with a thick atmosphere, not a thin wisp, like the trace of gas around Mars, not the near-perfect vacuum that surrounds our own moon, a real, deep, substantial atmosphere, thicker at the surface than the air you're breathing right now. The pressure at Titan's surface is about 1.5 times the pressure at sea level on Earth. If you stood there, the air would press against you slightly harder than it does at home, about the way it would feel to be standing at the bottom of a swimming pool 15 feet down. Except without the water, just air, dense and heavy and close around you. And it is cold air, brutally cold, and it is mostly nitrogen, just like the air you breathe, though without a trace of oxygen, so you could never actually breathe it. But here is the wonder of it. That air is dense, much denser than Earth's air, because the cold packs the molecules tightly together. And Titan's gravity is low, about 1/7 of Earth's, roughly the same gentle pull you would feel standing on our own moon. Put those two facts together, the thick, heavy air and the weak, gentle gravity, and you arrive at one of the most delightful truths in all of planetary science. On Titan, a human being could fly, not in a machine, not in a glider. You personally, with a pair of wings strapped to your arms, could launch yourself off the ground and fly through the sky of Titan by flapping, the way a bird does, the way you have dreamed of doing your entire life. The air is so thick and the gravity so weak that your own muscle power would be enough to lift you off the surface and carry you soaring over the dunes and the rivers and the methane seas. It would feel less like flying and more like swimming, a slow, buoyant, dreamlike drift through a heavy golden medium, your wings pushing against air that pushes back like water. Of all the worlds we know, Titan is the one where the oldest human dream finally comes true. You could fly there. You could actually fly. And everything would move slowly. In that low gravity, things fall lazily, gently, taking their time. If you jumped, you would rise high and come down slow, hanging in the air far longer than your instincts expect, settling back to the ground like a feather. If you dropped a stone, it would drift down rather than fall, unhurried, almost reluctant. Rain falls slowly here too, which we will come to. Everything on Titan happens at a gentler pace, a dreamier pace, as though the whole world were submerged in something thicker than air, as though time itself ran a little slower out here at the cold edge of the sun's reach. There is a heaviness and a slowness and a softness to Titan that is unlike anywhere else, a place where you would move through your days in long, floating, weightless arcs, drifting more than walking, sinking more than falling, the heavy amber air always there to catch you and hold you up. And the sound. This is the part almost no one thinks about. Titan is the only place beyond Earth where if you took off your helmet, which would of course kill you, but if you could, you would actually hear something. On the Moon, on Mars, in the vacuum of space, there is nothing to carry sound, no air thick enough to move, and so those places are silent in the most absolute way imaginable, a silence with no possibility of sound at all. But Titan has that deep, dense atmosphere, and sound travels through it beautifully. In fact, because the air is so thick, sound carries farther and richer there than it does on Earth. The wind across the dunes would have a voice. The rain falling into the seas would make a sound. Your own footsteps crunching across the damp, icy ground would echo back to you. The Huygens probe even carried a small microphone, and as it descended, it recorded the sound of the wind of Titan, the actual sound of air moving across an alien moon, a low and breathy rushing, the first sound ever heard from the surface of another world in the outer solar system. A soft wind blowing across a frozen plain 900 million miles away, recorded and carried home so that human ears could hear it. The wind of Titan. It sounds, people say, almost exactly like the wind on Earth, a little deeper, a little slower, but unmistakably wind. The sound of a real place, with real weather, sighing in the dark. And then there is the cold. We have said the number minus 179 degrees Celsius, but a number is not a feeling. And it is worth sitting with what that cold really means, because it shapes everything. It is a cold so deep that it changes the identity of ordinary things. Water is not water here. It is stone. The very ground is made of it, frozen so hard that it rings like rock when struck. The cold is so complete that the chemistry of life, the fast, warm reactions that keep your own body running every second, would slow here almost to stopping, every process stretched out, every reaction reluctant, the whole frantic pace of warm-blooded living slowed to the patience of ice. It is a cold beyond winter, beyond any winter the earth has ever known, a cold that belongs to the deep outer dark, to the places the sun can barely reach, and yet Wrapped warm and safe as you are, lying in the dark and only imagining it, that cold is not frightening. It is simply vast and still and clean. The cold of Titan is the cold of perfect stillness, the cold of a world holding its breath, the cold of deep space brushing gently against a frozen shore. And with the cold comes the silence and the solitude, and these too are worth holding for a moment, because there is nowhere in human experience quite like them. On Titan there is no life. As far as we know, not a single living cell, not a microbe, not a trace. In all that landscape, the seas and the dunes and the river valleys and the frozen plains, nothing has ever lived. Nothing has ever moved on its own. Nothing has ever made a sound on purpose. The wind blows, and the rain falls, and the rivers run, but no creature has ever drunk from them. No eye has ever watched them. No foot, but a falling probe from earth, has ever touched that ground. It is a solitude so total that it loops back around into peace. You are utterly alone on Titan, more alone than any human being has ever been or could ever be, hundreds of millions of miles from the nearest other person, on a world where nothing lives. And instead of terror, there is a strange and enormous calm in it. No one needs you here. No one is waiting. No one is calling. There is nothing to do and nowhere to be and no one to answer to. There is only you and the orange light and the slow sea and the cold, clean silence of a world that has been quietly, peacefully empty since the beginning of time. Let that solitude wrap around you like a blanket. Let it be a comfort rather than a fear. You are alone in the most complete and gentle way imaginable, and you are safe, and you can rest. Now look up into that orange sky, and let us talk about the rain. Because the rain on Titan is, in its slow and gentle way, one of the loveliest phenomena anywhere in the solar system, and understanding it is the key to understanding the entire world. On Earth, you know the water cycle. You learned it as a child. The sun warms the oceans, water evaporates and rises as invisible vapor. High in the cold air, it condenses into clouds. The clouds gather and thicken, and eventually the water falls back down as rain, which runs across the land, gathers into streams and rivers, and flows back to the sea, where it waits to evaporate and rise and fall again. A great slow wheel turning forever, moving water from sea to sky, to land and back to sea. It is the engine that shapes the surface of our planet. It carves the canyons and feeds the forests and fills the lakes. Water, endlessly cycling, is the reason Earth looks the way it looks. Titan has the exact same cycle. The exact same wheel turning in the exact same way, with every part in its proper place. There is just one substitution. Where Earth uses water, Titan uses methane. It is far too cold on Titan for water to be anything but stone. But methane, which on Earth is a gas we pipe into our homes to burn on the stove, on Titan sits right at the temperature, where it could be a liquid, a gas, and occasionally a frost, all at once, all in the same world, just the way water does on Earth. And so on Titan, methane evaporates from the seas. It rises as vapor into the cold sky. It condenses into clouds, great slow methane clouds that gather over the poles and drift across the orange heavens. And eventually those clouds let go, and it rains. Liquid methane falls out of the sky of Titan, drop by drop, and runs across the frozen ground, and gathers into streams, and carves those branching river valleys we saw from above, and flows downhill into vast standing seas, The same wheel, the same dance of sky and land and sea, just turning with a different liquid at a different temperature under a different and dimmer sun. But the rain itself, the actual falling of it, is unlike anything you have ever stood in. Picture it. The drops are large, far larger than raindrops on Earth, because the liquid is different and the air is thick, and the conditions favour big, fat droplets, and they fall slowly. Remember the gravity, only 1/7 of Earth's, and the dense, heavy air pushing back against everything that moves through it. So the rain of Titan does not come down in sharp, fast streaks the way it does at home. It drifts down, great soft globes of liquid methane, falling in slow motion, sinking through the heavy air almost gently, almost lazily, taking their time. The way snow falls on the very stillest winter night, except these are not flakes, but slow, fat drops of cold, clear liquid, descending in a hush through the amber light. You could watch a single drop fall for what would feel like a long, long moment. You could, in principle, reach out and watch it settle into your open hand. The rain of Titan falls like something in a dream, unhurried and silent and strange. A slow, gentle downpour out of a glowing orange sky onto a plain of ice at the bottom of the solar system. And it does not rain often. This is the other thing. Titan's weather is patient on a scale that dwarfs our own. The seasons there are long because Saturn takes about 29.5 Earth years to circle the Sun once, which means a single year on Titan, a single full cycle of its seasons, lasts nearly 30 of our years. Each season, spring, summer, autumn, winter, stretches out over more than 7 Earth years. 7 years of slow change, 7 years for the clouds to migrate from one pole to the other. The rain may come rarely, perhaps only in great seasonal storms, perhaps decades apart in any one place. And when it does not rain, the methane simply sits there, in the seas and the damp ground, slowly evaporating, slowly cycling, waiting for the long turn of the seasons to bring the clouds back around. A world of immense, unhurried patience. A world where the weather keeps a clock so slow that a human standing on the surface might wait a lifetime to see a single storm. And yet the storms do come. The rivers are real and something cut them. The seas are real and something fills them. The wheel turns just very, very slowly out there in the long amber dusk. And there are clouds. Across the long years that Cassini watched, it saw them come and go, great slow methane clouds, gathering and dissolving in the orange sky, drifting over the poles, sometimes spreading across whole regions of the moon. In the depth of a Titan season, clouds would build over the summer pole, thicken, darken the amber sky, and let go their slow rain, and the channels would run, and the lakes would fill, and the shorelines would creep outward. And then, over the following Earth decades, as the long season turned, the clouds would migrate toward the other pole, following the weak warmth of the hidden sun, and the rain would shift with them, and the weather would slowly, slowly move across the face of the world. Cassini even watched some of the smaller lakes change. It saw shorelines shift. It saw what looked like lakes shrinking as their methane evaporated in the long dry seasons, and others that seemed to fill. A whole world of slow weather, caught in the act of changing, photographed across 13 years, the seasons of Titan turning before our eyes for the very first time in human history. We are the first generation ever to watch the weather of another world change with its seasons. No one before us ever could. The clouds of Titan drifted and rained for 4 billion years, with no one to see them. And then, for 13 years, we watched. There is a deep stillness to standing inside that slow weather. On Earth, weather is fast. Storms blow in over hours, clouds race across the sky, rain comes and goes between morning and afternoon. But Titan's weather moves at the pace of decades. A cloud you saw over the pole might still be drifting there in some form years later. A rain that fills a lake might not come again to that spot for a generation. To stand on Titan and look up at the gathering clouds is to look at something almost geological in its slowness, weather so patient it is more like climate, more like the turning of an age than the passing of a day. And there is rest in that. The same rest you feel watching slow clouds drift across a summer sky, except slowed 1,000-fold, stretched out across years, the most unhurried weather in the solar system, drifting silently over a frozen world, in no hurry at all to arrive or to leave. Imagine being there when a storm finally comes. It would not arrive the way an earthly storm arrives, with a sudden darkening and a rush of wind and rain within the hour. It would build over days. First, the sky, already orange, would begin to thicken in one quarter, the amber deepening toward a heavier brown as the methane clouds gathered far off over the pole. The light would dim, very slowly, the soft, even glow growing softer still. The air, always calm, might begin to stir, the persistent, gentle wind freshening across the plain. And then, after a long, patient build-up, the clouds would spread overhead, vast and slow, and the first drops would come. Great fat globes of liquid methane drifting down out of the brown sky, falling so slowly in the thick air and the low gravity that you could watch each one descend, sinking past you like slow rain in a dream, landing with a soft sound on the icy ground and pooling in the hollows. And it would keep on. Not for an hour, but perhaps for days, the slow methane rain drifting down and down, soaking into the damp organic ground, gathering in the channels, beginning to run. And this is the moment the whole landscape was waiting for. The dry riverbeds, empty for years, perhaps for a human lifetime, would begin to fill. The trickle would become a stream, the stream a river, dark methane pouring down out of the highlands, carrying the dark sediment with it, carving the valleys a little deeper, exactly as it has done 10,000 times before. The rivers of Titan would run, full and dark and alive, down towards the great seas, and the dry lake beds would begin to flood, and the shorelines would creep outward across the plains. After the long, dry patience of the seasons, the world would briefly, slowly come to flowing life, all of it in that dreamy slow motion, the rain drifting, the rivers running soft and unhurried, the whole gentle machinery of the world turning over once more in the dim brown light. And then it would pass. The clouds would thin and drift on toward the other pole, following the slow turn of the season. The brown would lift back toward amber, the amber toward gold. The rain would stop, and the rivers would run on for a while, then slow, then dwindle, then fall quiet again, leaving the channels damp, the lakes a little fuller, the land freshly carved, and the long dry patience beginning once more. A single storm on Titan might be the work of a generation, the great event that a whole human lifetime on that world might be built around. And to witness one, to stand in that slow methane rain under the brown sky and watch the dead rivers wake and run, would be to watch a world breathe once deeply in the unhurried rhythm of a place where a single breath takes years. There is nothing frantic in it. Even the storms of Titan are calm. Even its rare wild weather moves with the patience of sleep. So follow the rivers down, follow them the way water always leads you home, downhill, toward the low places, toward the basins where the liquid gathers and rests. Follow them north, toward the top of the world, because that is where Titan keeps its seas. Near Titan's north pole lies the largest body of standing liquid anywhere in the solar system beyond the Earth. Its name is Kraken, and it is a sea in every sense of the word. It is enormous, larger than all 5 of the Great Lakes of North America combined, a vast, dark expanse of liquid methane and ethane filling a broad depression in the polar lowlands, with bays and inlets and straits, and a long, ragged coastline thousands of miles around. Beside it lies Ligeia, the second great sea, smaller but still immense, hundreds of miles across, deep and dark and cold. And beyond that, Punga, and scattered all across the polar region hundreds upon hundreds of smaller lakes, some only a few miles wide, nestled into the frozen ground like a landscape of mountain tarns, each one a still dark pool of liquid hydrocarbon under the orange sky. Together these northern seas and lakes hold most of the standing liquid on the entire moon, a great gathered reservoir of the rain of ages pooled at the top of the world. Stand on the shore of one of these seas and try to take in what you are seeing. The surface is black, not because the liquid itself is black, but because it is so perfectly, impossibly still that it acts like a mirror reflecting the dim orange sky and the smooth dark haze, a flawless sheet of darkness stretching out to a horizon you can barely make out. The seas of Titan are among the calmest, flattest, stillest surfaces ever observed anywhere. When spacecraft bounced radar off them, the reflections came back so clean, so undisturbed, that scientists could tell the surface was smoother than any sea on Earth has ever been. Smoother than glass, ripples measured in fractions of an inch across hundreds of miles of liquid. Imagine that. A sea the size of a continent's worth of lakes, lying so utterly still that it could be a sheet of black glass, no crashing waves, no whitecaps, perhaps in the right season when the winds pick up, the faintest slow swell, a gentle rolling of the surface, waves no higher than the length of your hand, drifting in slow motion across the methane, in the thick, heavy air. But mostly stillness, a vast, dark, silent, mirror-flat stillness holding the reflection of the amber sky. And you could sail it. This is not a fantasy. Scientists have seriously studied the idea of floating a probe on the seas of Titan, a small boat, a drifting raft of instruments riding the methane swells of Kraken, because the liquid is real and the seas are deep, and a vessel could genuinely float there. The liquid methane is less dense than water, so a boat would ride differently, sit a little lower, bob a little more slowly. The waves, when they came, would rise and fall in that same dreamy slow motion as everything else on Titan, great gentle swells lifting your little craft and setting it down again unhurried, the thick air and the low gravity stretching every motion out into something languid and calm. You could drift across the surface of an alien sea, under an alien sky, the orange haze glowing softly above you, the black liquid lapping with a low, strange sound against the hull, the far shore lost somewhere over a hazy horizon, and all around you, in every direction, the stillness and the cold and the silence of a world at the far edge of the sun. Sailors have crossed seas on Earth for 10,000 years. Somewhere, perhaps in some distant century, a machine of ours, or someone of ours, will cross a sea on Titan and become the first sailor of another world. And we know more about these seas than you might think, because Cassini did something extraordinary. It bounced its radar down through the clear methane and listened for the echo from the bottom. And in doing so, it measured the depth of the seas of Titan, the depth of bodies of liquid on another world. Ligeia Mare, the second of the great seas, turned out to be deep, more than 500 feet deep in places, deep enough to swallow a building, and so pure and so clear and so calm that the radar passed straight through it to the seabed and back. The methane there is astonishingly transparent, far clearer than any water on Earth, a still dark liquid you could see down through for a great distance if you had the light to do it. These are not shallow puddles. They are deep, clear, cold seas, with floors and depths and basins as real and as substantial as any sea on Earth, just filled with a different liquid and lying under a different sky. And here is a curious thing about where they lie. Almost all of Titan's seas and lakes are gathered at the North Pole. The far south, the opposite pole, is strangely dry, holding only a few small lakes and a scatter of empty basins, dry depressions that look as though they once held liquid and lost it. For a long time, this puzzled everyone. Why should one pole be wet and the other parched? The answer seems to lie in the slow rhythm of Titan's seasons, in the subtle way its orbit around the sun is shaped, which causes the two poles to be warmed slightly differently over the long cycle of the years, so that methane is, over the ages, very gradually moved from one pole and gathered at the other. The seas of Titan, it seems, may slowly migrate, pole to pole, across spans of time so long they dwarf the seasons themselves, the whole ocean of a moon shifting hemispheres over tens of thousands of years. There is even a southern lake, named Ontario Lacus. After the lake on Earth, it resembles in size and shape, sitting nearly alone near the South Pole, a lonely outpost of liquid in the dry southern lands. And like the seas of Earth, the seas of Titan all share a single level. Scientists were able to show that the great northern seas, spread across thousands of miles, all lie at the same height, the same elevation, just as all of Earth's oceans share one sea level. This means they are connected, if not on the surface, then beneath it, the liquid seeping through the porous, icy ground from one sea to the next, finding its level the way water does, so that all across the north of Titan there is, in effect, one single connected body of liquid, one water table, except made of methane, balancing itself across the whole top of the world. A sea level on a moon of Saturn. The same quiet physics that shapes our own oceans, working out there in the cold, in the dark, under the orange sky. And there are mysteries in those seas. When Cassini watched them over the years, it sometimes saw strange things, bright features that appeared on the surface of the seas and then vanished, showing up in one set of images and gone in the next. The scientists nicknamed them magic islands. No one is entirely sure what they were. Perhaps rafts of frozen material floating up from below, perhaps streams of bubbles rising from the depths, fizzing up out of the cold liquid the way gas comes out of a soda when it warms, perhaps waves or floating solids or some seasonal stirring of the sea that we still do not fully understand. Islands of mystery, appearing and disappearing on the face of a methane sea, glimpsed across 1 billion miles of space, still not entirely explained. Titan keeps its secrets. Even now, even after we have landed on it and mapped it and sailed our radar beams across its seas, it holds things back, things we have seen but cannot name, out there in the dark water, at the top of the world. Walk the shoreline of one of these seas for a while in your mind and notice how familiar and how strange it is, both at once. There are bays here and headlands and long curving beaches. There are places where rivers reach the sea and spread their load into broad flat deltas, fans of channels splitting and rejoining, exactly like the great river deltas of Earth seen from the air. There are drowned valleys where the methane has risen and flooded into the low country, leaving a ragged coastline of inlets and islands, the same shape a rising sea makes anywhere. There are steep-walled lakes, almost perfectly round, with sharp raised rims that scientists think may have formed where the ground collapsed or was eaten away from below, filling with liquid to make deep, dark, steep little pools, like flooded quarries scattered across the polar plains. And there are dry lake beds too, smooth, pale basins where a lake once stood and has since evaporated away in the long, dry turn of the seasons, leaving a bright floor of stranded material, a bathtub ring of organic residue, marking where the liquid used to reach. And the seas themselves are not all the same. Some are pure and clear, almost entirely methane. Others are richer, thicker, with more ethane and other heavier compounds dissolved in them, and these would look and behave a little differently, a touch more sluggish, a touch darker. The shallows near the shore might be one mixture, the cold depths another, layered like the waters of an earthly sea, and dissolved through all of it, tinting it, thickening it, is that endless fall of organic material from the sky, so that the seas of Titan are not just liquid fuel, but a kind of cold, organic broth, a slow chemical soup, the rain of the haze gathered and pooled and stirred over the ages into the largest bodies of organic liquid anywhere, we know. If there is anywhere on Titan where the long chemistry of the haze might take its next quiet steps, it is here, in these dark, patient seas, where the fallen molecules gather and mix and wait, in the cold, under the orange sky, for whatever time and chemistry might slowly make of them. Stand at the very edge, where the liquid meets the land. Watch the methane lap gently at the icy shore, rising and falling in its slow, cold rhythm. Behind you, the frozen plain. Before you, the dark sea. Above you, the amber sky. And right here at your feet, the 3 great realms of Titan meet and touch. The solid ice, the liquid methane, the gaseous sky, the same meeting of states that on Earth happens where the sea meets the beach beneath an open sky, the same eternal edge, the same soft boundary where a world's 3 faces come together. It is the most familiar place in the universe, rendered in the strangest possible materials. A beach. Just a beach. At the bottom of the solar system, on a moon of Saturn, under a sky the colour of honey, a beach where the slow tide of an alien sea comes in and goes out and comes in again, and has done so patiently, beautifully, for longer than there has been life on Earth. Now let us leave the seas of the north and travel south down toward the warm belt of the world, toward Titan's equator, because the landscape there is different and just as strange and just as beautiful. If the poles are where Titan keeps its seas, the equator is where Titan keeps its sand. Vast, endless fields of dunes, great long parallel ridges of dark sand marching across the equatorial regions for thousands of miles, some of them stretching nearly unbroken across an entire continent. These are some of the largest dune fields anywhere in the solar system. They have names now, given to them by the people who mapped them from orbit: Belay, Shangri-La, Fensel, dark seas of sand hundreds of miles across, the dunes within them rising 100 meters tall, a few hundred feet, great long ridges running side by side, sculpted by the slow winds of Titan into shapes that look almost exactly like the sand seas of the Sahara seen from space. The same long parallel ridges, the same flowing patterns wrapping around obstacles. If you saw a radar image of Titan's dunes next to a satellite image of the deserts of Earth, you would struggle to tell them apart. But the sand is not sand. Of course, it is not. Nothing on Titan is what it first appears to be. The dunes of Earth are made of ground-up rock, tiny grains of quartz and mineral worn down over the ages. The dunes of Titan are made of something far stranger. They are made of organics. They are made of those tholins, the dark, complex molecules that form high in the orange haze and rain down slowly out of the sky, the soot of Titan's endless atmospheric chemistry. Over the ages, that fine, dark material settles to the surface and gathers, and clumps into grains, and the winds gather the grains and pile them into dunes, so that the great equatorial deserts of Titan are made not of stone but of soft, dark hydrocarbon, the fallen residue of a sky that has been making organic molecules without pause for billions of years. The dunes are the size of the deserts of Earth, and they are built entirely out of the kind of carbon-rich molecules that, on our own world, are the chemical building blocks of life, whole continents of them, sculpted into ridges by the wind, dark, soft, and silent under the orange sky. Walk out into them in your mind, stand among the dunes of Titan. The ridges rise around you, long and dark and smooth, curving away to the hazy horizon. The grains beneath your boots are fine and dark, and in the low gravity, if you scuffed them, they would lift and drift and settle back slowly, hanging in the thick air longer than dust ever hangs on Earth. The wind, when it blows, is gentle but persistent, and over the slow centuries it pushes these mountains of dark sand a few grains at a time, the whole vast desert creeping imperceptibly across the face of the moon, the dunes migrating over thousands of years the way the dunes of Earth migrate, only slower, always slower, everything on Titan slower. There is no sound but the wind. There is no light but the amber glow. There is no colour but the deep, warm brown-orange of the sand and the sky. And there is space. Enormous, open, silent space, the dunes running on and on past the limit of sight, an entire frozen continent of soft, dark sand with not a single living thing upon it, not a footprint, not a track, not a sound, just the slow wind and the slow dunes and the long, even, endless dusk. It is one of the loneliest and most peaceful landscapes the mind can imagine. A desert at the bottom of the solar system where it has been quietly, patiently evening for 4 billion years. And Titan is not only seas and dunes and plains, it has mountains too, real mountains, ridges and peaks rising out of the icy surface, though they are not made of rock the way Earth's mountains are. They are made of water ice, pushed up and folded by the slow movement of Titan's crust over the ages, and worn down by the same methane rain that carves the river valleys. The tallest of them rise a couple of 1,000 feet, even higher in places, and the people who mapped them gave them names borrowed from imagined worlds, from the mountains of Middle-earth in Tolkien's stories, so that there is a range on Titan called Mithrim Montes, and a peak called Doom Mons, names from fantasy given to real mountains on a real moon of Saturn, because the whole place feels so much like something out of a story. Picture them rising softly out of the orange haze, pale icy ridges catching the even amber light, their slopes scored by the channels of ancient methane streams, standing silent over the dark plains, mountains of ice on a world of fuel older than any mountain that has ever stood on Earth. And scattered across the surface in certain places, there are stranger features still, features that may be the work of that hidden ocean speaking to the surface. There are broad, low domes and flows that look as though something once welled up from below and spread out and froze in place. There is a feature called Sotra Patera, a deep pit beside a tall mound that some scientists believe may be the closest thing we have yet found to an ice volcano, a cryovolcano, where instead of molten rock, it is cold, slushy water and ammonia that erupts from the depths, oozing onto the surface and freezing into these strange, smooth shapes. We are not certain. Seen dimly through the haze by radar from a passing spacecraft, these features are hard to read, and scientists still argue over what they are. But it is possible that here and there across Titan, the buried ocean has pushed its way to the surface, leaving these quiet frozen fountains as its signature, cold volcanoes that erupt not fire but ice, building soft, pale mounds on the floor of the orange world. There are also regions called labyrinth terrains, mazes of ridges and valleys cut into the icy ground that may be a kind of frozen version of the cave country you find on Earth, the karst landscapes where water slowly dissolves the rock and hollows it out into caverns and sinkholes and winding gorges. On Titan, the same slow dissolving may happen, but with methane doing the work that water does on Earth, eating away at the soft organic ground over the ages, carving out hollows and ridges and perhaps deep down caves. Dark methane-cut caverns no eye has ever seen hidden beneath the surface of a moon of Saturn. The more closely we look at Titan, the more varied it becomes. Seas and rivers and rain at the poles, vast dune deserts at the equator, mountains of ice, possible ice volcanoes, labyrinths and perhaps caverns. It is not a simple frozen ball. It is a whole world, as complicated and as varied in its own strange way as the Earth, with as many different kinds of landscape, as many different stories written into its surface, all of them waiting in the long orange dusk for someone to come and read them. There is something else strange about Titan's surface, something you only notice when you compare it to every other world of its kind. It is almost smooth. It has almost no craters. Look at our own moon, or at Mercury, or at the icy moons all around Titan, and you see worlds saturated with impact scars, craters upon craters upon craters, billions of years of bombardment recorded in the rock, because in space nothing ever erases them. But Titan is nearly clean. In all the years Cassini spent mapping it, it found only a handful of large impact craters across the entire globe, places with names like Menrva and Selk, when there should have been thousands. And there is only one explanation. Something is erasing them. Titan's surface is young, geologically young, made over and wiped smooth again and again by the very processes we have been walking through. The rain washes the craters away, the rivers fill them with sediment, the dunes bury them. The methane weather, working over millions of years, scrubs the record clean, exactly the way wind and water and weather erase the old scars on the face of the earth. Of all the worlds in the solar system, only Earth and Titan have surfaces this young, this alive, this constantly remade. The two of them are the only places where the land itself keeps changing, keeps healing, keeps rewriting its own story. Everywhere else, the past just sits there, frozen and scarred. On Titan, like on Earth, the world keeps starting over, and it has its own great landmarks. There is a region near the equator called Xanadu, a bright, reflective highland roughly the size of Australia, a whole continent of rugged hills and valleys and chasms, crisscrossed by ancient river channels standing out pale against the darker dune fields around it. We do not fully understand Xanadu. It is old and rough and washed by methane rain, and it may be one of the most ancient surviving pieces of Titan's surface, a continent that has somehow resisted being buried, holding its ground while the dunes and the seas remake the rest of the world around it. Imagine a land the size of a continent, pale and hilly and scored with dry riverbeds sitting under the orange sky, older than almost anything else on the moon, named for the imagined paradise in an old English poem, a place of mystery on a world that is mostly mystery. And high above all of it, the winds do something the surface never does. Down where you are standing, on the ground, the air is calm, the breeze gentle, but far overhead, in the upper reaches of that deep atmosphere, the winds move with astonishing speed, racing around the moon far faster than the moon itself turns. The whole upper atmosphere is, in a sense, spinning, sliding around the globe in great fast rivers of air, while the surface below sits almost still. Scientists call it superrotation, and it is rare and strange, found in only a few places in the solar system. So the sky of Titan has two natures. Near the ground, a calm, slow, gentle stillness, the soft breeze that barely stirs the dunes. And far above, hidden in the orange haze, a great silent racing of winds circling the world, carrying the clouds and the haze around and around the moon, a fast and ceaseless motion you would never feel and never see from the quiet shore below. Now, here is where Titan becomes stranger still, because everything we have walked across so far, the icy plains, the river valleys, the seas of methane, the dark dunes, all of it is only the surface, only the skin of the world. And beneath that skin, deep down, far below the frozen ground, Titan is hiding something that no one expected. Something that changes the entire story, something that turns this cold, dead-seeming moon into one of the most intriguing places in the search for life anywhere in the solar system. Beneath the icy crust of Titan, scientists now believe, there is an ocean. A real ocean, an ocean of liquid water. Let that settle for a moment because it sounds like a contradiction. We have spent this whole journey establishing that Titan is far too cold for liquid water, that water on Titan is rock, that the very ground is frozen ice harder than granite, and on the surface that is true. But go down, deep down, 50 miles, 100 miles below the surface, and things change. The deep interior of Titan is warmer than the surface, heated from within by the slow decay of radioactive elements in its rocky core, and by the gentle, ceaseless flexing of Saturn's tides pulling on the moon as it orbits. And down there, under the crushing weight of all that ice, under the pressure and the gentle warmth, the water is liquid. A vast, dark, global ocean of liquid water wrapped entirely around the moon, buried beneath an outer shell of ice perhaps 50 or 100 miles thick. An ocean with no sky, no light, no waves, no shore that any eye could ever see, sealed in eternal darkness between the cold crust above and the rocky core below. Some estimates suggest this hidden ocean could hold more liquid water than all the oceans of the earth combined. A buried sea, larger than every sea on our world, locked inside a frozen moon of Saturn, where no one ever thought to look. So Titan has two oceans, in a sense, two completely different kinds of liquid, layered one above the other. On the surface, the cold black seas of methane under the open orange sky, and far below, hidden and lightless, a deep, warm ocean of liquid water, the kind of water you could drink, the kind of water that on Earth teems with life. They are separated by 100 miles of ice, two worlds within one world, the familiar made strange and the strange made familiar, stacked one atop the other in the dark, and every now and then the deep water may find a way toward the surface. Scientists believe Titan may have cryovolcanoes, ice volcanoes, places where instead of molten rock it is liquid water and slush that wells up from below, oozing out onto the frozen surface and freezing there, building strange smooth domes and flows of ice, carrying material up from the hidden ocean into the light. We are not certain. The evidence is debated, the features ambiguous, glimpsed dimly through the haze. But it is possible that the buried sea of Titan speaks to the surface every so often through fountains of freezing water, leaving its signature on the land, a slow, cold conversation between the deep ocean and the open sky, carried out over geological ages in a language of ice. And this is where one of Titan's deepest mysteries lives, the methane. Remember the methane, the liquid that rains from the sky and fills the seas and drives the whole great weather wheel of the world. There is a problem with that methane, a beautiful, unsolved problem. Sunlight, even the weak sunlight that reaches Titan, slowly destroys methane in the upper atmosphere, breaking it apart, molecule by molecule, the pieces drifting down to build the haze and the dunes. At the rate it is being destroyed, all the methane in Titan's atmosphere should be gone within a few tens of millions of years. A blink in the lifetime of a moon that is 4.5 billion years old. And yet the methane is still here, the sky is still full of it, the seas are still full of it, which means something, somewhere, must be replenishing it. Something must be making new methane and releasing it into the air continually to replace what the sunlight destroys. And no one knows for certain what that something is. Perhaps the cryovolcanoes belching methane up from the interior, perhaps reactions deep in the rocky core. Or perhaps, and this is the possibility that makes scientists lean forward in their chairs, perhaps something in that buried ocean, some slow chemistry, or even some slow biology, is making it. We do not know. The methane that fills the sky of Titan and falls as its rain and gathers in its seas comes from a source we have not yet identified. A hidden engine somewhere inside the moon, quietly replacing what is lost, keeping the great orange world wrapped in its weather, keeping the wheel turning for reasons we have not yet learned to read. It is worth asking as you lie there in the dark how a world like this ever came to be. How did Titan get its thick atmosphere when no other moon in the solar system has anything like it? The answer reaches back to the very beginning, 4.5 billion years ago, when the sun was newly lit and the planets were still forming out of a great disk of gas and dust. Saturn, like Jupiter, gathered so much material that it grew its own miniature disk around itself, a swirling ring of gas and ice from which its moons would condense, like a small solar system within the larger one. And out there, so far from the sun, it was cold. Cold enough that the material building Titan was rich in ices, not only water ice but frozen ammonia, and frozen methane and other volatile compounds that closer to the sun would have boiled away. Titan formed cold, and it formed rich, gathering up a great store of these frozen volatiles into its body as it grew. And then, slowly, over the ages, that buried store began to breathe out. The ammonia, worked on by sunlight high in the early atmosphere, may have broken down to release nitrogen, which is why Titan's air, like Earth's, is mostly nitrogen today. The methane seeped up from the interior to fill the sky and feed the rain. Titan was large enough and cold enough and far enough from the sun's heat to hold on to all of this, to keep its thick blanket of air wrapped around itself for billions of years, while smaller, warmer moons, closer to their planets, lost whatever atmospheres they might once have had to the emptiness of space. Even Ganymede, the one moon in the solar system larger than Titan circling Jupiter in the warmer inner reaches, never managed to keep an atmosphere like this. Titan did. It is a creature of the deep cold and the deep past, a world that formed in exactly the right place, with exactly the right ingredients, to become the one moon with weather, the one moon with seas, the one moon with a sky you could lean against. A small accident of where it formed and what it was made of, and because of it a whole world of rain and rivers exists, where there might have been only dead ice. And it is held always by Saturn. Titan does not orbit alone in the dark. It circles the great ringed planet once every 16 days or so, locked by gravity in a slow and faithful dance, always keeping the same face turned toward Saturn, the way our own moon always keeps the same face turned toward Earth. And as it orbits, Saturn's immense gravity pulls and flexes it, very gently, kneading the moon, working its interior, and that slow flexing helps to keep the buried ocean warm and liquid, helps to keep the whole world geologically alive. The bond between Titan and Saturn is ancient and unbreakable, a tie of gravity stretching across more than 700,000 miles of space, the giant and its great orange moon turning together through the dark, as they have turned since before the Earth was born, as they will turn long after it is gone. Now look up again and let us talk about the sky and about what you can and cannot see from the surface of Titan, because this too is strange and a little sad and quietly beautiful. You are standing on a moon that orbits Saturn. Saturn, the most magnificent object in the solar system, the great golden planet with its impossible rings, hangs somewhere out there in space, enormous, close, far larger in Titan's sky than the full moon ever appears in ours. From the surface of Titan, Saturn would loom in the heavens like a vast, pale lantern, its rings cutting a thin, bright line across the planet's banded face, a sight so overwhelming that it should, by rights, dominate every view, fill every horizon, be the first thing you saw and the last thing you remembered, and you cannot see it. You cannot see Saturn at all, because the haze, that thick, perpetual orange smog, seals the whole sky from edge to edge, and from the surface of Titan you can never once glimpse the great planet you are circling. You would stand there, in the amber dusk, knowing that the most beautiful object in the solar system was hanging directly overhead, vast and close and glorious, and the only thing you would ever see of it is the soft, diffuse glow it might cast through the clouds, a slightly brighter patch in the orange murk, nothing more. The grandest sight in the heavens, hidden behind a curtain of smog, forever just out of view. And the sun, too, is hidden. From the surface of Titan you would never see the sun as a disk, never see it rise sharp and golden over the dunes or set red into the methane sea. You would see only the general brightening of one part of the sky, a vague, luminous smear that crept slowly across the orange dome over the course of a Titan day, which lasts about 16 Earth days, the sun making its slow, invisible journey behind the haze, and then the slow fading as it set, the orange deepening toward a darker amber, never quite black, the long dusk dimming toward a longer dusk, and then slowly brightening again days later, as the hidden sun came round once more. No stars, no planets, no sun, no Saturn, no moon, just the orange sky, brightening and dimming on its slow 16-day rhythm, the most enclosed and intimate sky of any world we know, a sky that wraps the whole moon in a single warm shroud and lets nothing of the wider universe through. To stand on Titan is to stand inside a sealed amber room, beautiful and complete, and utterly cut off, a world that cannot see the cosmos it belongs to. There is something strangely peaceful in that when you sit with it. On Earth, the night sky reminds us constantly of how small we are, how vast the dark is, how many stars and how much emptiness surrounds our little world. The sky is a window onto immensity, and immensity can be frightening. But on Titan, there is no window. The sky is close. The sky is warm-coloured and soft and near, curving gently overhead, like the inside of a shell. You could not feel the terror of the infinite on Titan because the infinite is hidden from you. You would feel, instead, enclosed, held, wrapped in a small warm-toned world of orange light and slow rain and quiet seas, with the rest of the universe politely curtained away. It is, in its strange and lonely fashion, one of the most sheltered places imaginable. A whole world tucked beneath a blanket of haze where the dunes drift, and the methane falls, and the long dusk goes on, and nothing outside ever intrudes. And now we come to the question that hovers over all of this, the question that makes Titan more than just a beautiful curiosity, the question that has drawn scientists toward it for decades and is about to draw a remarkable machine across the gulf of space to land there. Could there be life on Titan? It is the oldest question we ask of any new world, and on Titan it takes a form stranger and more provocative than almost anywhere else. Because Titan has so many of the things life seems to need. It has abundant organic molecules, the carbon-based chemistry that every living thing on Earth is built from, raining out of its sky and piling into its dunes. It has liquid on its surface, vast, standing seas where complex chemistry could unfold over the ages. It has a thick protective atmosphere, an energy source in the sunlight and the lightning that may flicker in its clouds, and a deep ocean of liquid water hidden below. It has, in some real sense, more of the raw ingredients of life laid out on open display than anywhere else in the solar system. And yet it is so cold, so bitterly, brutally cold, that the chemistry of life as we know it should grind almost to a halt. So scientists ask the question in two different ways, pointing at the two different oceans of Titan. The first way points downward at the buried sea of liquid water deep beneath the ice. That ocean is dark and hidden, but it is liquid water, warmed from within, possibly in contact with the rocky core, possibly rich in dissolved minerals and organic compounds filtering down from the surface. It is, in its broad features, not so different from the buried oceans of other icy moons like Jupiter's Europa or Saturn's own Enceladus, places we already consider among the most promising homes for life beyond Earth. If life were going to arise on Titan in a form we might recognize, built on water, as all earthly life is, the buried ocean is where we would look. A lightless sea, never touched by the sun, where strange, slow creatures might drift in the dark, if anything drifts there at all. We do not know. We may not know for a very long time. But the possibility is real, and it is one of the reasons Titan keeps a permanent place on the short list of worlds where we might, someday, find that we are not alone. The second way of asking the question points upward at the surface, at the cold methane seas, and it is far stranger, far bolder, and far more imaginative. What if there were life on Titan that did not use water at all? All life on Earth, every bacterium, every redwood, every whale, every human being, uses liquid water as the medium in which its chemistry happens. Water is the solvent of life as we know it, the liquid inside every cell, the sea every living process swims in. But Titan does not have liquid water on its surface, it has liquid methane. And some scientists have dared to ask, what if that were enough? What if, in the cold methane seas of Titan, an entirely different kind of life arose, one that used liquid methane the way Earth life uses water, with a completely alien biochemistry, cells held together in ways no earthly cell ever needed, running on chemical reactions that to us would look impossibly slow and impossibly cold. Researchers have even sketched out on paper how such a cell membrane might be built, a membrane that could hold together in liquid methane at minus 180 degrees without any water at all. They gave it a name, they worked out the chemistry. It remains entirely hypothetical, a thought experiment, a beautiful maybe, but it raises one of the most profound questions in all of science. Is life on Earth the only way to be alive? Or is our water-based, warm-blooded, carbon and water chemistry just one solution among many? One melody in a music that could be played in other keys, on other worlds, in liquids we would freeze to death inside? Titan is the one place in the solar system where we might actually find out. The one place where a second, independent, utterly alien kind of life could be waiting. in the cold black seas under the orange sky. And this is not idle speculation, because we know some of what is actually floating in Titan's air, and the list is startling. When our instruments studied the atmosphere, they found it laced with complex molecules, far more than simple methane and nitrogen. They found hydrogen cyanide, a molecule that on Earth is a poison but is also, intriguingly, one of the most important stepping stones in the chemistry that may have led to life, a building block that can link up into the components of proteins and even genetic material. They found benzene and other carbon rings. They found a molecule called acrylonitrile, sometimes called vinyl cyanide. And this is the one that made researchers sit up, because it is exactly the molecule that those theoretical alien cell membranes, the ones built for liquid methane, might be made of. And acrylonitrile is genuinely present in Titan's sky, in large amounts, raining down toward the seas, the very ingredient that a methane-based life might use to build itself a body. And then, in the year 2020, using a great array of telescopes high in the mountains of Chile, astronomers found something no one expected. A small, strange, ring-shaped molecule called cyclopropanylidene, floating in Titan's upper atmosphere. It is a rare and fragile thing, a little ring of carbon that almost never survives anywhere it can bump into other molecules, so rare that it had only ever been found before in the cold, near empty spaces between the stars. And yet there it was, in the air of Titan, a delicate ring of carbon, of exactly the kind that, built upon and elaborated, leads toward the rings that form the backbone of the molecules of life. Titan is the only place with an atmosphere where we have ever found it. Floating up there in the orange haze, fragile and strange, is a molecule that points, however faintly, toward the chemistry of living things. The more closely we look at the air of Titan, the more it reads like a recipe, half-written, a list of ingredients laid out and waiting, the same ingredients that somewhere, somehow, once came together into something that could breathe. Even if there is nothing alive on Titan at all, not in the buried ocean, not in the methane seas, the moon is still priceless to science, for a reason that is quietly astonishing. Titan may be a frozen snapshot of the early Earth. Before life arose on our own planet, before there was oxygen in the air, the young Earth had an atmosphere rich in nitrogen and methane and other simple molecules, an atmosphere where sunlight and lightning worked on those molecules to build more complex ones. The slow chemical prelude that eventually, somehow, led to the first living things. That chemistry, the chemistry of the world just before life, is almost impossible to study on Earth now, because life itself came along and consumed the evidence and rewrote the whole surface of the planet. But on Titan, that early chemistry may still be running, right now, out in the open, frozen in slow motion by the terrible cold, preserved and unfolding across an entire world. The orange haze, the tholins, the organic dunes, the methane seas, all of it may be a living laboratory of the kind of chemistry that came before life, the chemistry that built the building blocks, the chemistry that, on one world at least, eventually woke up and looked around and became us. To study Titan may be to look back across 4 billion years at a frozen image of our own beginnings. The cradle, preserved in ice, There is an experiment, a famous one, that makes this idea feel very close and very real. In 1953, two scientists named Stanley Miller and Harold Urey filled a set of glass flasks with the gases they believed had filled the air of the young Earth. Simple things, methane and ammonia and hydrogen and water vapor, and they ran sparks through it, imitating lightning. And within days, the clear liquid in the flasks turned brown, and when they examined it, they found amino acids, the building blocks of proteins, the building blocks of life, formed spontaneously out of nothing but simple gas and a spark of energy. It was one of the most startling results in the history of science. It suggested that the chemistry of life is not some rare and improbable accident, but something that simple molecules will do readily, eagerly, given energy and time. The ingredients of life seem to want to assemble themselves, and here is the connection that makes Titan glow in the mind of every scientist who studies it. The brown gunk that formed in those flasks, the complex organic residue, is chemically not so different from the tholins that rain out of Titan's orange sky. Titan is running the Miller and Urey experiment, but not in a flask for a few days. It is running it across the entire world, continuously, for billions of years. The methane is there. The nitrogen is there, the energy is there in the sunlight and perhaps in flashes of lightning in the clouds. And the organic molecules are forming exactly as they formed in the flask and falling onto the surface and gathering into dunes and washing into rivers. When researchers have taken laboratory tholins, the kind made to imitate Titan's haze, and simply added liquid water to them, they have watched amino acids and even the components of the molecules that carry genetic information appear, forming on their own, the next steps assembling themselves the moment water touches the organic soot. On Titan, that water is mostly locked away as ice or buried deep below. But every so often, when a meteorite strikes and melts the ice, or when warm water from the interior reaches the organic surface, the two may meet, the water and the tholins, just long enough for the chemistry to take a few steps forward before the cold freezes it again. This is why we keep returning to Titan in our imagination and soon with our machines. It may be the single best place in the entire solar system to watch the chemistry that comes before life, frozen part way through its work, preserved in the cold like a film stopped mid-frame. On Earth, we can never see those first steps because life came and erased them 4 billion years ago. But on Titan, the early chapters may still be lying open, written across a whole world, the same chemistry that once, on our own planet, kept going, and eventually became everything that has ever lived. To read Titan may be to read the prologue of our own story, the part we lost, the part that came before the first living thing drew breath. It is worth pausing here in the quiet to think about how we know any of this at all, because everything I have described to you tonight, the orange haze and the river valleys, the methane seas and the dark dunes, the buried ocean and the slow rain, none of it could be seen from Earth. For 300 years, Titan was a featureless dot. Everything we now know we learned in the span of a single human generation, through one of the most patient and beautiful acts of exploration our species has ever carried out, and it began with a spacecraft called Cassini. Cassini was enormous, the size of a school bus, one of the largest and most complex machines ever sent into deep space. It launched from Earth in 1997, carrying with it a smaller probe, the Huygens lander, tucked against its side like a passenger. And then it fell through the dark for 7 years. 7 years, swinging past Venus twice, past the Earth once more, past Jupiter, gathering speed from each encounter, crossing the immense gulf out to Saturn. 7 years of silence and patience and falling, while back on Earth, the engineers who built it waited and grew older and watched the slow dot of its position creep across the map of the solar system, closer and closer to the rings. In 2004, it arrived. Cassini slipped into orbit around Saturn, the first spacecraft ever to do so, and began a mission that would last 13 more years, looping around the ringed planet again and again, flying past its moons, mapping, measuring, photographing, sending its discoveries home across the long radio gap, a gap so wide that its signals, travelling at the speed of light, took well over an hour to reach the Earth. And in January of 2005, Cassini did a thing it had carried its little passenger 7 years to do. It released the Huygens probe and let it fall toward Titan. For 3 weeks, the small probe coasted alone toward the orange moon, and then it hit the atmosphere and deployed its parachutes and began the slow 2.5-hour descent we travelled together at the start of this journey, sinking through the haze, recording the wind, watching the river valleys resolve out of the murk, until it settled onto that damp, icy plain and became the first and only machine ever to land in the outer solar system. It kept transmitting from the surface for over an hour, sending back its precious data, its images, its sounds, until its batteries failed and it fell silent. There, on the surface of Titan, where it sits to this day, a small, cold monument from Earth, 900 million miles from the hands that built it, slowly gathering the dark soot of the haze, waiting in the orange dusk for a visitor who has not yet come. And Cassini itself kept going for 12 more years, circling Saturn, returning again and again to fly low over Titan, peering through the haze with radar that could map the surface no camera could see, watching the seasons turn, discovering the seas, tracing the coastlines, measuring the hidden ocean, building, flyby by flyby, the entire portrait of Titan that we have been exploring tonight. And when at last its fuel began to run low, the people who guided it made a remarkable choice. They did not want to risk the spent spacecraft someday crashing into Titan or into Enceladus, the other moon that might harbour life, and contaminating those pristine worlds with stray microbes from Earth. So they chose instead to send Cassini into Saturn itself. In September of 2017, after 20 years in space, the great spacecraft turned toward the planet it had studied for so long and dove into its atmosphere, transmitting data the entire way down, measuring the very air it was burning up in, sending home new science in the final seconds of its existence, until the heat and the pressure tore it apart, and it became, in the end, a part of Saturn, a streak of light in the golden sky, a brief falling star over the very moons it had spent its life exploring. The people in the control room wept. They had spent decades of their lives on that machine, and it went out doing science, faithful to the last, somewhere above the clouds of Saturn, with Titan hanging nearby in the dark, orange and silent, keeping the secrets it had only just begun to share. But the story of Titan is not over. It has barely begun, because we are going back. Right now, on Earth, in clean rooms and laboratories, engineers are building the next machine to visit that orange moon. And it is unlike anything we have ever sent to another world. It is called Dragonfly. And it is not a lander sitting still in one place. It is not a rover crawling slowly across the ground. Dragonfly is a flying machine, a rotorcraft, a kind of large drone with 8 spinning rotors designed to take off from the surface of Titan and fly. Remember the thick, heavy air and the low, gentle gravity, the very conditions that would let a human being fly by flapping wings. Those same conditions make Titan the easiest place in the entire solar system to fly a powered aircraft. The air is so dense and the gravity so weak that rotors bite easily into the sky, and a flying machine can lift off and soar over the landscape with far less effort than it would take on Earth. And so, rather than send in a probe that can study only the patch of ground it happens to land on, we are sending a machine that can fly from place to place, exploring dunes and craters and plains across many miles of Titan, landing wherever the science is most interesting, taking off again, moving on, a tireless mechanical explorer flitting across the face of an alien moon. Dragonfly is planned to launch in the year 2028, and because of the vast distance we spoke about, the long fall across the solar system, it will not arrive at Titan until around the year 2034, 6 years in transit falling through the dark, the way Cassini fell before it. And when it arrives, it will descend through that orange haze, and it will land among the dunes near a region called Selk Crater, a place where the surface organics may once have mixed with liquid water from below, exactly the kind of place where the chemistry that leads to life might have taken its first steps. And then it will begin to fly. Hop by hop, flight by flight. Over the course of years, Dragonfly will explore Titan's surface directly, tasting its sand, sampling its air, studying the organic chemistry of that frozen world up close, looking for the chemical signatures of the processes that, on Earth, led to life. It will be the first aircraft ever to fly on another world's atmosphere in a controlled, powered way. The first machine to truly explore a distant moon the way a bird explores a landscape, rising and soaring and settling again and again beneath the amber sky. Somewhere in the next decade, if all goes well, there will be a flying machine from Earth, drifting over the dunes of Titan and the long orange dusk that has gone unwatched for 4 billion years will have at last a visitor with wings. And Dragonfly is only the beginning of what we dream of sending. Scientists have sketched out on paper missions that sound like something from a storybook. They have studied, quite seriously, the design of a submarine for Titan, a small craft that would not fly over the seas but float upon them, and then dive beneath them, sinking down into the cold, black methane of Kraken, exploring the depths of a sea on another world, mapping its floor, measuring its currents, drifting through liquid that no light has ever reached. Imagine that. A submarine built on Earth sailing the methane sea of a moon of Saturn, sending back to us the first images ever taken from beneath the surface of an alien ocean. They have imagined balloons that would drift on Titan's winds, riding the thick air for months, circling the globe in the amber dusk. They have imagined boats and buoys and landers and rovers, a whole future fleet of small brave machines, each one carrying a little of our curiosity out across the dark to that orange world. We may not build all of them, we may not build most of them, but the fact that we can seriously plan them, that the seas are real enough to sail and the air is thick enough to fly and the surface is solid enough to land on, tells you what kind of place Titan is. It is not a hostile abstraction, a number in a textbook, a dot too far away to matter. It is a destination. A shore we are slowly, genuinely making our way toward, across the longest distance human beings have ever tried to cross. And somewhere, in the centuries ahead, if our species keeps reaching the way it has always reached, there may be more than machines out there. There may be people. There may be one far day, a human, standing where you are standing now in your imagination on the shore of a methane sea, under an orange sky, looking out across the stillness, the first of us to truly stand on the second shore. Think of that as you lie there in the dark. Think of that machine already half built, waiting in a clean room on Earth, destined to fly over a sea of methane under an orange sky almost 1 billion miles away. Think of the slow years it will spend falling through the black before it arrives. Think of the first flight it will make, lifting off from the dark dunes into the heavy golden air. The first powered flight in the history of that world, carried out in silence in the cold by a small brave machine, acting on behalf of a species it will never see again. There is something almost unbearably moving in it. We are a small warm species on a small warm world, and yet we keep reaching out across these impossible distances toward the cold, strange places, just to see, just to know, just to touch the second shore and learn what it is made of. Titan has been waiting 4 billion years, and we are coming back. But Dragonfly has not arrived yet, and tonight you do not have to wait 6 years or cross 900 million miles to be there. You are already there. So let us stop travelling and stop explaining and simply be on Titan for a while. Let us spend the slow hours of its long day in the amber dusk and let the world move at its own unhurried pace and ask nothing of you but that you rest and listen and drift. Stand once more on that wide, flat plain near the edge of a methane sea. Feel the heavy air around you, dense and cold and still. Feel the gentle pull of the low gravity, lighter than home, so that your whole body feels buoyant, unweighted, as though you could rise off the ground with the smallest push. The orange light falls evenly from the whole sky, soft and shadowless, the colour of honey, the colour of late afternoon stretched out forever. There is no glare. There is nothing harsh, only the warm, even glow, and the dark, still sea before you, and the pale, icy ground beneath your feet, scattered with its smooth, rounded stones. Walk slowly toward the shore. In the low gravity, each step carries you farther than you expect, a long, gentle float forward, your foot coming down soft on the damp, icy sand. The ground here is firm but yielding, like packed sand at the tide line, slightly soft, slightly giving, faintly damp with methane that fell as rain in some past season, and has not yet evaporated away. With each step, the dark grains crunch quietly beneath you, and the sound carries clearly through the thick air, a small, crisp sound in the great silence. And it is silent here, deeply silent, the kind of silence that has weight, broken only by the faint sigh of the wind moving across the plain and the still darker quiet of the sea ahead, No birds, no insects, no distant traffic, no voices, no machines, no sound that any living thing has ever made. Only the wind and your own slow breathing and the soft crunch of your steps on the shore of an alien sea. Reach the edge of the liquid and stop. The methane sea lies before you, black and flat and motionless, so still it perfectly mirrors the dim orange sky, so that the horizon almost disappears, and the world seems to fold into itself, amber above and amber below, with only a faint dark line where the two meet. The liquid does not look like water. It is clearer, thinner, and it lies more flatly, more heavily, lapping at the icy shore with a slow, low sound, a gentle, cold rhythm, rising and falling, rising and falling, the patient breathing of a sea that has been here for longer than your species has existed. Crouch down in your imagination and watch the surface. Every now and then a faint, slow ripple crosses it, a swell pushed by some distant breath of wind, rolling toward you in dreamy slow motion through the heavy air, lifting and lowering the dark surface and then passing, and the sea returns to its mirror stillness. The cold rises off the liquid, a cold beyond cold, the deep settled chill of a place the sun has never truly warmed. And above it all the orange sky glows softly on, neither brightening nor fading. The long, even dusk, holding the whole world in its gentle amber light. Now sit down on the cold shore in the soft orange glow, with the black sea before you and the dunes somewhere behind you, and the haze curving overhead like the inside of a shell, and simply rest. There is nowhere to go. There is nothing to do. The nearest other place is a moon or a planet, hundreds of millions of miles across the dark. You are as far from the noise of the world as it is possible to be. You are sitting at the edge of a sea on a moon of Saturn, wrapped in a warm-coloured sky held in a gentle gravity, in a silence so complete and so old that it feels less like absence and more like peace. The sea breathes slowly, in and out, lapping the icy shore. The wind sighs across the plain. The light glows softly on. And nothing in all this vast and patient world needs anything from you at all. You can simply be here. You can simply rest on the shore of Titan, in the long orange evening while the slow sea breathes beside you, and the cold settles soft as a blanket, and the amber light holds you and holds you and holds you. Let us stay here a while on this shore, and let a whole Titan day pass over us, slowly, the way it really would. A day on Titan is not like a day on Earth. It does not last 24 hours, it lasts almost 16 of our days, because that is how long Titan takes to turn once as it circles Saturn. So the light here changes with a slowness that is almost beyond feeling. There is no dawn that breaks, no sudden brightening, no sun that climbs the sky. There is only the faintest, gentlest shift over the course of many Earth days as the hidden sun creeps invisibly behind the haze. The orange brightens so gradually that you could not catch it happening from a deep amber toward a paler gold as the long Titan morning comes on, and it stays. For days and days it stays, the soft gold light lying evenly over the seas and the dunes, never harsh, never moving, a noon that lasts the better part of an Earth week, and then just as slowly, just as imperceptibly, it begins to deepen again, the gold sliding back toward amber, toward a richer orange, toward the long Titan evening as the unseen sun sinks once more behind the curtain of the sky, And the night, when it finally comes, is not black. Even at the deepest point of the Titan night, with the sun fully on the far side of the world, the sky does not go truly dark. It settles into a deep, dusky, reddish gloom, the colour of embers, the colour of the very last moment of a sunset just before it dies, and it holds there, dim and warm and close, for days before the slow turning brings the light creeping back. To stand on Titan through a full day and night would be to watch the gentlest cycle of light anywhere in the solar system, a rhythm so slow and so soft that it would lull you the way a very slow breath lulls you, the world brightening and dimming over the span of 2 of our weeks, the amber sky breathing light in and out, with all the patience of a world that has nowhere to be and all of time to get there. Picture yourself staying here through all of it, through the long pale morning, the gold light spreading over the still seas, through the endless even noon, the dunes glowing softly, the rivers trickling, the rain perhaps drifting down somewhere far off over the poles. Through the deepening evening, the amber thickening, the light withdrawing into the haze, and through the dusky ember night, the world settling into its deep red gloom, warm and quiet and close, the sea still breathing against the icy shore, the wind still sighing across the plain. Nothing changing, nothing hurrying, nothing asking anything of you at all. You could lie here through a whole Titan night, 2 weeks of our time, and the world would simply hold you, dim and warm and patient, while the hidden sun made its slow way around to morning. There is no rush on Titan. There has never been any rush. There is only the slow turning and the soft light and the long, long rest. Let your mind drift now to time, because Titan is a world of deep and patient time, and there is something restful in giving yourself over to it. This sea before you has been here, in one form or another, for an unimaginable span. Titan formed alongside Saturn more than 4.5 billion years ago out of the same swirling disk of gas and ice that built the rings and all the other moons, condensing out of the cold outer reaches of the young solar system while the Earth was still a ball of molten rock. And in all the time since, while continents rose and drowned on Earth, while the dinosaurs came and ruled and vanished, while the ice ages advanced and retreated, and the first human beings learned to walk upright and make fire and look up at the stars, Titan was here, doing this, exactly this. The methane rising and falling, the slow rain drifting down, the rivers carving their valleys grain by grain, the dunes creeping across the equator, the seas lying still beneath the orange haze. 4 billion years of quiet weather, 4 billion years of slow rain on a frozen shore. The amount of patience held in this one cold world is almost beyond comprehension. Every valley you saw from above was carved not in a season or a century, but across millions of years, drop by drop, the most gradual possible sculpting of a landscape, an art so slow that no single eye could ever watch it happen. And it is not finished. It will go on. Titan will keep raining and cycling and drifting for billions of years more, long after tonight, long after you, long after everyone you have ever known. There is a strange comfort in that, the same comfort you might feel standing before an ancient mountain or an old and enormous tree. The knowledge that some things are vast and slow and enduring, that the universe holds places of immense calm and immense patience, that the frantic small urgencies of a single day are held inside a stillness so much larger, that they simply dissolve. Titan does not know you are watching. Titan does not know anything at all. It simply continues as it has continued since before the earth had oceans, the rain falling slow, the seas lying still, the long dusk going on. And you are allowed, for these few quiet minutes, to rest inside that enormous calm, to let your own small urgent day grow soft and distant, to borrow some of that 4 billion-year patience for yourself, and breathe, and let go. And here is one last thought, a strange and beautiful one, to carry with you towards sleep. Titan is frozen now because the sun is far away and weak. But the sun will not always be as it is. Billions of years from now, our sun will begin to age, to swell, to grow into an enormous red giant star, vastly larger and far more luminous than it is today, flooding that outer solar system with warmth it has never known. And when that happens, the inner worlds, Earth among them, will be scorched and ruined, the oceans boiled away, the home of all our history burned to bare rock. But out at the cold edge on Titan, something else may happen. As the dying sun grows and warms, Titan may thaw. The temperature may rise to the point where water ice melts, where the frozen ground becomes liquid, where Titan, for a few 100 million years, becomes a temperate world. A world with liquid water on its surface, a world with a thick atmosphere and abundant organic chemistry and seas and rain and warmth all at once, all together in the last long afternoon of the solar system. Some scientists have wondered, quite seriously, whether Titan might become genuinely habitable in that far future, whether life might arise there in the warmth of the dying sun, billions of years after the earth is gone, a second cradle waking up just as the first one falls cold. We will not be there to see it. No human eye will ever watch it happen. But it is a lovely thing to know, lying here in the dark, that the frozen orange world we visited tonight may, in the deep future, have its own warm morning, that the second shore may yet feel the rain fall warm, that somewhere in the long story of the solar system, after everything we know has ended, Titan may finally thaw and bloom and have its day. There is something fitting, too, in the name this moon was given, Titan. We did not always call it that. For a long time after Christian Huygens first spotted it, it was known simply as Saturn's moon, and later, when more of Saturn's moons were found, as the sixth one, a number rather than a name. It was only in the 1800s that an astronomer proposed calling it Titan, after the Titans of ancient Greek myth, the elder gods, the enormous and ancient beings who ruled the cosmos before the more familiar gods came along. The Titans were the children of the sky and the earth, vast and primordial, the generation that came first, the powers of the deep past. And the name turned out to be more apt than anyone could have known, because this moon is exactly that, ancient, enormous, a holdover from the deep past, a world built at the very beginning, still wrapped in the kind of chemistry that came before everything else. The largest moon of Saturn, named for the elder gods, holding inside its frozen seas a chemistry older than life itself, Titan. It is a good name for a world that has been quietly keeping the secrets of the beginning for 4.5 billion years. And it is the largest of all of Saturn's many moons, a family of more than 140 worlds, from tiny lumps of ice only a few miles across to this one giant, larger than the planet Mercury, larger than any moon in the solar system except Jupiter's Ganymede. If Titan orbited the Sun on its own instead of circling Saturn, we would not hesitate to call it a planet. It is a world in every sense, with a surface and an atmosphere and weather and seas and a hidden ocean, more geologically alive and more chemically rich than many of the official planets. It simply happens to orbit a planet instead of the Sun, and so we file it under the modest heading of moon, as though that word could contain it. But Titan is no mere moon. Titan is a world that got caught in Saturn's gravity, a planet in everything but a dress, circling the ringed giant out there in the cold, keeping its own weather, running its own slow chemistry, living its own enormous, patient life, whether or not anyone is watching. And there is one more reason Titan matters, a reason that reaches far beyond our own solar system, out into the wider galaxy. For most of human history, we assumed that Earth was unique, that the particular things our world has, rain and rivers and seas and weather and an active surface, were rare and precious accidents, unlikely to be found anywhere else. But Titan quietly overturns that assumption, because Titan shows us that a world does not need to be like Earth, does not need to be warm, does not need liquid water on its surface, does not need to sit in the narrow, comfortable zone near a star in order to have rain and rivers and seas and an active, weather-driven, ever-changing surface. Titan does all of that out in the deep cold, with the wrong liquid, far from the sun, in conditions we would once have dismissed as utterly dead. And if Titan can do it, then the galaxy may be full of worlds doing it, full of moons and planets with skies and seas and weather of every strange description, running on liquids we have not imagined, under suns of every colour, most of them nothing like Earth, and all of them alive with process, with change, with the patient flow of liquid over land. The universe may be far wetter, far more active, far more various than we ever dared to think. Not wet with water necessarily, but wet with something, raining something, pooling something into seas. Titan is the proof, the single example close enough to touch, that the conditions for a living, weather-shaped world are broader and more generous than we ever believed, and that out there in the dark, around other stars, there may be 10,000 other shores, each one strange, each one raining its own strange rain, each one waiting. That is the gift this quiet orange moon gives us. It widens the world. It takes the cozy little diagram of the solar system you carried since childhood, the one with Earth as the only living blue jewel and everything else as dead rock and cold gas, and it gently tears it up and shows you that the truth is stranger and richer and far more beautiful. There is a second shore in our own solar system. There is a second place where it rains, and if there are two, here around one ordinary star, then there are surely numberless others, scattered through the dark in every direction, more worlds with weather than there are stars you can see with your eyes. You will never visit them. You will never see them. But they are there, raining and flowing and changing in the dark, and knowing that they are there, knowing that the universe is that full and that various and that alive, is one of the quiet wonders you are allowed to carry with you into sleep. Before we rest, let us take one more slow walk together. Away from the sea this time, inland, up the course of one of Titan's rivers, because the rivers are where the moon tells its story most clearly, and there is a deep calm in following flowing ground. turn away from the still Black Sea and walk up the shallow valley that feeds it. The ground rises gently here, the pale ice bedrock showing through in places, and running down the centre of the valley is a channel, a riverbed, sometimes dry and sometimes damp, winding down from the higher country in long, lazy curves. Follow it upstream. In the low gravity, your steps are long and soft, and the orange light falls evenly, and the only sounds are the wind and your own slow breathing, and here and there the faint trickle of liquid methane finding its way down over the icy stones. For the river is not always dry. After the rare great rains of the long Titan seasons, these channels run full, dark methane pouring down from the highlands, and in the years between they hold quiet pools and slow trickles, the last of the rain making its patient way toward the sea. The valley walls rise around you, low hills of water ice, smoothed and rounded by ages of flow, and the riverbed beneath you is paved with those pale, rounded stones, every one of them ice, every one of them tumbled smooth by liquid that ran here long before you came. There are bends where the river has cut deeper, small bluffs of layered ice, the strata of countless seasons laid down and carved away. There are wide, flat places where the channel spreads and slows and the methane would pool into still dark ponds. There are tributaries joining from the side valleys, smaller channels feeding the main one, the whole branching network, gathering the rain of an entire region and carrying it down to the sea, exactly as a watershed does on Earth, exactly as the rivers of your own world have always done. It is so familiar that you keep forgetting where you are. It looks like a riverbed in the high desert at dusk, the light low and golden, the stones pale, the air still. And then you remember. The stones are frozen water, the river is fuel, the dusk is permanent, the desert is a moon, and the nearest other human being is hundreds of millions of miles away, across a darkness it would take a falling spacecraft 7 years to cross. And yet you are not afraid. That is the strange gift of this place. There is no menace in Titan, for all its lethal cold. It is too calm for fear, too slow, too soft. The light is gentle. The gravity is gentle. The rain, when it comes, is gentle. The sea breathes gently against the shore. Even the storms, when they finally break after their long seasonal silences, move with a kind of dreamy slowness in the thick, heavy air, the great methane clouds gathering over the poles, darkening the orange sky to a deeper amber, releasing their slow, fat drops in a downpour that drifts rather than falls. To witness a rainstorm on Titan would be to watch weather in slow motion, the drops sinking lazily through the dense air, the methane gathering in the channels, the rivers beginning to run, the whole patient machinery of the world turning over once more, unhurried, unbothered, exactly as it has turned 10,000 times before. There is nothing frantic here, there is nothing urgent, there is only the slow turning, the long dusk, the gentle rain, the quiet sea, a whole world running at the pace of a held breath, at the pace of a slow tide, at the pace of sleep itself. Imagine for a moment what it might be to live here, not to visit, not to fall through the haze in a probe and land for an hour, but to truly live on Titan, in some far century, in a warm, sealed habitat, on the shore of a methane sea. And here is something that surprises almost everyone. To step outside on Titan, you would not need the bulky armored pressure suit that an astronaut wears on the airless moon. The air pressure on Titan is gentle, only a little greater than the pressure in the room where you are lying right now, so nothing would be trying to tear the air out of your body or crush you. The only things that would kill you are the cold and the lack of oxygen. So a visitor on Titan might step out in something more like warm clothing and an oxygen mask, a heated suit and a supply of air, and simply walk out onto the shore far more freely than they ever could on any other world we know. No other place in the solar system beyond the Earth would let you stand outside so simply. Only Titan, with its thick, gentle sky, lets you keep something close to the feeling of just being outdoors. And then, of course, there is the flying. You already know that the thick air and the low gravity would let you rise off the ground on a pair of wings. Picture using it not as a feat, but as an ordinary way to get around the way we use a bicycle, drifting low over the dark dunes of Belait and Shangri-La, following a river valley down toward the polar seas, crossing the mirror-flat face of Kraken Mare in long, slow, dreamy arcs, the orange sky soft above you and the frozen world soft below. Of all the strange and distant futures the universe might hold, that one is real. That one is allowed by physics. Somewhere, someday, a human being may cross the seas of Titan on wings in the long amber dusk and look down at the second shore and feel, perhaps, the same deep calm you are feeling now. So, let us return one last time to the shore. Let us sit again at the edge of that still black sea in the warm orange light and gather together everything we have seen tonight and hold it quietly for a moment before we let it go. Think of where you are. You are sitting on a moon of Saturn, nearly 900 million miles from home, on the only other world in the solar system where rain falls from the sky and rivers run across the land and seas, lie waiting in the low places of the ground. Above you, hidden behind a veil of orange haze, hangs the great ringed planet you orbit, vast and unseen. Around you stretches a landscape carved by liquid, dunes of dark organic sand and valleys cut by methane rivers, and a frozen plain scattered with stones rounded smooth by ancient floods. Beneath you, far below the icy crust, lies a buried ocean of liquid water, larger than all the oceans of Earth, dark and silent and warm. And over it all the long, even dusk, the soft amber glow that never brightens and never fades, holding the whole world in a single, gentle light. It is the most Earth-like place we have ever found, and it is nothing like Earth at all. It has rain, but the rain is liquid fuel. It has rivers and seas, but they would freeze you to glass. It has beaches and shorelines and rounded stones, but the stones are ice and the sand is soot. It has a thick, blue-feeling sky, but the sky is orange and seals out the stars. It is a mirror of our world held up across the dark, showing us a reflection of everything familiar, rendered in materials so cold and so strange that the familiarity becomes its own kind of wonder. Every diagram of the solar system you ever saw left this place out, or shrank it to a nameless dot, and all the while it was here, a whole world wrapped in weather, with seas you could sail and skies you could fly through, and a slow, patient chemistry running in the dark, waiting for someone to finally pull back the orange curtain and look. And the most remarkable thing of all is that we did. A small warm species on a small warm world looked up at a featureless orange dot and wondered, and built a machine the size of a bus and threw it across 900 million miles of empty space and let a little probe fall through the haze and learned that the dot was a world. We heard its wind, we mapped its seas, we found its hidden ocean, and we are going back, with wings this time, to fly over its dunes and taste its strange dark sand. That is what your species does. It reaches, it wonders, it crosses impossible distances just to know what is there. And what is there this time is a second shore. A frozen mirror of home, a quiet orange world at the cold edge of the sun, raining slow methane onto an ancient sea, exactly as it has done since before the earth was born. And think for a moment of where home is from here. If you could rise up above the orange haze, up out of Titan's thick sky, into the clear dark of space, and look back toward the sun, you would see it shrunk to a small fierce point, 100 times fainter than the sun you know, but still by far the brightest thing in the sky. And close beside it, almost lost in its glare, you would find a tiny pale speck, a faint blue star, easy to miss, no brighter than 100 others. That speck is the Earth. That speck is everything. Every person you have ever known, everyone who has ever lived, every city and ocean and mountain, every story ever told, the entire stage of human history, all of it gathered onto that one small blue point of light, almost too faint to see, nearly 900 million miles away across the cold and the dark. From Titan, the whole of your world is a single dim star, low beside the sun, easy to overlook. And yet, from that pale and distant speck, something reached all the way out here. That is the part that should stay with you. From that tiny blue dot, lost in the glare of a shrunken sun, a species of warm and curious creatures looked out across the impossible distance and wondered what was here, and built a machine, and sent it falling for 7 years through the black to find out. The faint blue star reached across the solar system and touched the orange moon. The smallness of us and the reach of us, both true at once. We are almost nothing, a speck beside a speck, and we have stood through our machines on the shore of a sea on a moon of Saturn, and heard its wind, and tasted its air, and learned its secrets, and begun to plan our return. There is something in that worth holding on to as you drift towards sleep. However small the day behind you may have felt, however small you may sometimes feel, you belong to a species that crossed 900 million miles of darkness just to see what was there. The reach is as real as the smallness. Both are yours. You do not have to remember any of it. You do not have to hold on to a single fact or a single name or a single number. Let them all grow soft now and blur together and drift. Let the distances dissolve. Let the cold become a kind of warmth, the warmth of being wrapped and held and far from every urgent thing. You are lying safe and warm in the dark, and somewhere out there, almost 1 billion miles away, a slow sea is breathing against an icy shore under a sky the colour of honey, and the rain is drifting down through the heavy air, one gentle drop at a time, and the long dusk is going on and on and on. There is no hurry there. There never was. There is only the soft amber light, and the still dark sea, and the quiet, and the slow turning of a patient world that asks nothing of you at all. Rest now. The orange sky will hold the light all through the night. The sea will keep its slow and gentle rhythm. And the second shore will be there in the morning, just as it has been for 4.5 billion years, waiting in the dark, beautiful and silent and far away. Let your breathing slow. Let the warmth settle over you. Let yourself drift, soft and weightless, down through the heavy golden air toward sleep. Good night.